If your Vapi assistant feels slow and laggy, then it's probably one of these four settings: latency, model choice, temperature, and max tokens. My name is Quincy. I'm the founder of Good Looking AI, and we build solutions for sporting gyms, medical facilities, and home services to automate the boring stuff. If you're into that type of stuff and want to learn how to create these voice AI solutions, be sure to subscribe and let's jump in and get started. All right, so what is latency? So latency is going to be the time between the user speaking and hearing something useful back. So in a voice pipeline, there are these different stages or hops. Right? So the first one being is when the user speaks into the mic, we use a speech to text provider, right? And then that text gets sent to the large language model, an LLM, such as GPT-5, GPT-4o, whatever it may be, where it processes the request, the text, and generates a response in text, right? So once we get that text from the large language model, and then we use a text-to-speech provider so that we can return the speech back to the user as output, right? And now where people start experiencing poor user experience is when a response typically takes longer than 300 milliseconds, right? And we even experience even more poor user experience when it takes around 1.5 seconds for a response. Now, to put a visual to it, we have the user and they speak into some form of tool or device such as a mic, which gives us the speech input. That speech input gets sent to a speech to text provider such as DeepGram, and then that text gets sent to the large language model such as GPT-5, where it processes the input as text, generates an output from the LLM in text as well. And that text gets sent to a text-to-speech provider such as 11 Labs, and then that generates our speech output that we return back to the user. So ideally, we want to keep this as low as possible so that we can provide a good user experience. Now, some possible culprits to look for that can affect the latency and the overall performance of your voice AI assistant is going to be prompt bloat and long system prompts and long chat histories. See, all of these things slow down the first token. So the rule is to always shrink the prompt, right? And this is something that I have come across in experiences with projects that I've worked on in the past where we had such a large prompt and all it did was just cause hallucinations for the AI assistant and just decrease the performance and just cause a lot of issues. So take it from my experience to always try to optimize your prompt and to keep it as short as possible. Now, for whatever reason, if you have a system that requires a long prompt that's filled with a lot of business knowledge and different complex tasks that the AI needs to implement, I always suggest breaking that large prompt into smaller manageable tasks or prompts that you can spread out across a team of assistants, and that would be using squads on Vapi, right? Allowing an assistant to specialize in that specific area of the prompt can help you still create powerful systems, but optimize the prompt as much as possible. But Vapi squads, that's a video for another day, which I'll make down the line. But for the sake of this video, just always try to shrink your prompt so that your AI assistant stays optimized. Okay, so now I'm in my Vapi account and I wanted to showcase two examples. So I have these assistants, Alex, and I have a trimmed version of the prompt, which we can see right here, fits all in one screen. And we have a bloated version of the prompt. And we can see that there's a little bit more wording to this prompt. Now, both of these assistants are using the GPT-4o mini cluster, as you can see right here. Now, I just want to quickly test just to show live examples of how your prompt can greatly impact the latency and the performance of your assistant. Okay, so to kick off our test, let's first test out our bloated prompt. Now, I'm going to be testing out both of the assistants with the same scenario so that we can get a good understanding of what type of responses we get out of a bloated prompt versus a trimmed, more precise focus prompt. So I'm going to call up the assistant.
Hi there, this is Alex from Tech Solutions Customer Support. How can I help you today?
Hey Alex, my Taskmaster Pro app keeps crashing right after I log in. I've already restarted my computer twice and I'm on a deadline, and this is just being really annoying.
I understand that's frustrating, especially with the deadline approaching. I'm here to help get this sorted out. Could you tell me when you first noticed this issue with the Taskmaster Pro app?
I started noticing it this morning, but so far I cleared the cache and reopened, and it still crashes when the dashboard loads.
Thanks for trying those steps. Just to confirm, is the app updated to the latest version? Sometimes updates can help with stability issues.
I'm not too sure if I updated it to the latest version.
No problem. Let's check that now. First, could you please open the app and go to the settings or about section? There should be an option to check for updates. Let me know what version you have.
Okay, so now I'm going to test out the trimmed prompt and just notice the type of responses that we get back from the AI assistant. Hey Alex, my Taskmaster Pro app keeps crashing right after I log in. I've already restarted my computer twice and I'm on a deadline, and it's being really annoying.
I get that's frustrating. Let's fix it. Try clearing the app's cache and then relaunch it. Let me know if that works.
Okay, I cleared the cache and reopened. It still crashes when the dashboard loads.
Try updating the app to the latest version. If it still crashes after that, I can escalate the issue for you.
Okay, I updated it and it's still crashing.
I can escalate this to our tech team for further assistance. Would you like me to open a ticket for you?
So as you can see, the first test with the bloated prompt had a longer response and seemed a little bit more uncertain about how to help me, versus the second attempt with the trimmed response or trimmed prompt. It had more short, concise responses that were straight to the point to help me get to the next step, which we always have to take into these type of things into consideration when we want our users to have good user experience and get the help that they need in a timely manner. So everything is geared around prompt engineering and ensuring that your prompt is short and as efficient as possible. Okay, so we just trimmed the wait time. Now let's fix the wrong answers. Model choice is where speed, accuracy, and cost balance out, and this is how I choose which model to use based on the scenario. Okay, so here I have a model choice cheat sheet for 2025 that I use to help me choose the correct LLM based off the use case. So here I have a few scenarios. I have some of the best models to use for those scenarios, and also some quick notes on why those models are a good choice for those specific use cases. So first one being is a real-time voice agent. So if you're watching this video, most likely you're interested in learning how to build voice AI assistants on platforms such as Vapi, Bland, Retel, whatever it may be, right? The best model for those type of use cases will be using GPT 4.1 mini or the 4.0 mini. Now, if I go back to my assistants that I showcased earlier, we can see that we're using the GPT 4.0 mini cluster, and we have 840 milliseconds. Right? So that's relatively really low and is going to provide really fast response times back to the user and provide a good user experience. If we further dive into it, we can see that the GPT 4.0 mini cluster has a low latency of 390 milliseconds. So it's really fast and the cost is really low. It's only a penny per minute, right? So this model, this LLM, is ideal for these real-time voice agent types of systems or projects, right? So it's fast, it's balanced, it's multimodal, meaning that it doesn't just work with text, it can work with a wide range of medias. So video, images, whatever it may be. And it's also mini, so it's lightweight, it's going to be very fast. And if we look at the 4.1 mini, Again, it's really fast, but we are sacrificing a little bit on the latency. Here we see that it's 770 milliseconds. Not bad, still will provide a really good user experience, and the cost is still low, but it's not as fast as the 4.0 mini cluster, and it's also not multimodal. So I typically tend to prefer this LLM right here. Now, if you need to build an AI assistant that's going to involve heavily on tool calling and function calling, and then the LLM that I would recommend would be the GPT 4.1, right? So it's really strong with tool usage and also function calling. So that's something to keep in mind if you're going to be connecting your AI assistant to a variety of tools where it needs to trigger these tools to implement some sort of task or function, and then using the 4.1 would be a really good LLM to use. Now, if you need an LLM that's deterministic, meaning a little bit more predictable, it's going to be working with forms, it's going to be working with API calls, and then a good model to use would be Claude 3.5 or 3.7, or if you like OpenAI, you can use GPT 4.1. Now, what does it exactly mean when one says deterministic? Now, it's important to understand that AI LLM models are non-deterministic in nature. What does that mean? So for every input, right, we can get a different output from the LLM. That's what non-deterministic means. I can provide an LLM the exact wording, the exact same instructions, but the output of the LLM is slightly different each time. So for every input, we can get a different output for each instance, right? So that's something to really understand, to get a better, just more knowledge on how these LLMs work, right? So with that in mind, if we need something a little bit more predictable, and then using something like the GPT 4.1 would be perfect. And then also keeping temperature low so that, again, it's more deterministic and it's predictable. If you need an AI model, an LLM that's going to be involved in deep reasoning, maybe let's say you need to generate summaries or in-call reports using a model like Gemini 2.5 Pro, 1.5 Pro would be good. Also, another good alternative, again, would be the GPT 4.1. Now, if you need an AI assistant that's going to be involved in RAG architecture, RAG stands for Retrieval Augmented Generation, meaning the AI needs to connect to external things, right, such as a vector database to retrieve data. If we have an AI assistant that needs to involve in that type of architecture, then using Gemini 1.5 Pro or GPT 4.1 would be ideal. I would recommend GPT 4.1 if you need to involve your voice agent in some type of RAG architecture. Okay. Now, if you need to create an AI agent that's a little bit more creative, and then using Claude 3.5 or 3.7 Sonnet would be an ideal LLM to use. But again, another good alternative is GPT 4.1. So these are pretty much the models that are my go-to. Most of the case, I'm using GPT 4.0 mini cluster for real-time voice agents, especially if it's simple, right? It's a basic voice agent. Now, if it's more advanced and there's more tool calling, and then I'll use GPT 4.0, GPT 4.1. And if I'm involving an AI model to generate summaries, and then I would use something like Gemini 1.5 Pro. So my rule is to always try to use the lightest model as possible. Now, when it starts to not pass your use case, and then bump your model up to something like a GPT 4.1, right? So ideally, you want to save the heavy models for more complex things, like a GPT 4.1 for more complex tasks, tool calling, summary generating. But if you need quick responses, and then using a lightweight model like 4.0 mini cluster would be ideal. So this is my model choice cheat sheet guide. Hopefully this helps you get a better understanding of what models you should be choosing based on the scenario that you have at hand. Okay, now we understand which models are best to use based on the use case. But now, why does the model sometimes over-explain? Well, that's temperature, and let's tune that up. Okay, so temperature is going to be what's used to control how adventurous the model will be when it chooses its words. Here I have a quick temperature guide that you can use as reference so that you can appropriately set the temperature for your AI assistant for what you're trying to achieve. So if you want something deterministic, your AI assistant to be predictable, follow a specific path or a script, or an AI assistant that's going to be working with tool calling and JSON data, and then we can set the temperature to something like anywhere between 0.0 and 0.2. Now, if you want your AI assistant to be a bit more conversational, but tight and still follow a specific path, and then we can increase the tokens to anywhere in between 0.2 and 0.4. But if you need your AI assistant to be a bit more creative, and then you can set your temperature to anywhere between 0.7 and 0.9. But realistically, for phone agents, we want it to be as low as possible to avoid rambling and malformed JSON. And ultimately, we want to provide a good user experience. So we want answers to be short and concise so that user is getting the response that they're looking for. So it's going to be a combination of appropriately setting the temperature and also prompt engineering and choosing the right model to get the most efficiency out of the AI assistant. Okay, so we set up the temperature, which essentially is the style of how our AI assistant responds. But how do we actually control the maximum number that can be outputted from our LLM? Well, that's going to be max tokens, and we'll start setting that up. Okay, so max tokens is what's going to be used to control the speed, cost, and cutoffs that your AI assistant can face if you do not choose the correct LLM and set your max tokens correctly. So there are two things to know, right? Context window is the input and the output together. Now, what does context window mean? Context window is the LLM's memory budget that it has available at that given request. And the context window makes up of the input and the output, right? So the input is going to be, for instance, on Vapi, it's going to be the JSON structure of the assistant, which consists of the system prompt, the tools, the chat history. That's going to make up the input that gets sent to the LLM, and then the LLM generates an output, right? So the input and the output needs to fit in the context window. So if you choose something like a 4.0 mini cluster, but then you have an assistant that has a long prompt, right? This can cause on the back end, the input or the output to be truncated. Truncated means cut down, shortened, so it fits the context window. And when this happens, this can cause the system or the AI, the LLM, to silently error, right? Which is not a good thing. So choosing the correct LLM is very important. Now, max tokens is going to be the output cap. How much can the LLM output? If we set it to something too short and we need a response that's, let's say the LLM generates a response that's over the max tokens that was set. Let's say we set max tokens to something like 50, and then the LLM needed to generate something that was like a paragraph long. It will return a cutoff, meaning it was not able to provide the full response because the max tokens was too low. Now, if you set your max tokens too high, and then this can lead to the AI assistant to ramble and provide lengthy responses that can lead to poor user experiences. So finding the sweet spot is going to be very crucial, right? So ideally, right, so 100 tokens is around 1 to 2 sentences. So you always want to offset a little bit more, right? So I like to typically set my AI assistants to have a response anywhere between 250 and 300 as the max tokens. But it's your responsibility to do your due diligence to find the sweet spot that works for that specific use case, that specific client project, just know that the context window is very important. Choose the right LLM, and then also the max tokens. You don't want cutoffs, and you also don't want too long of responses, right? So it's very important to understand these concepts of max tokens along with temperature and the LLM and also latency so that you can create valuable AI voice solutions. Okay, so to wrap it up, latency is going to be the delay from the user getting a response back from the LLM. Ideally, we want to keep this as low as possible. Number two is the model choice. We want to ensure that we're choosing the correct model for the use case. For most real-time voice agents with basic functionality, using something like GPT-4o mini cluster will suffice enough. But if you need an AI assistant with more advanced features, maybe generating in-depth summaries, maybe an assistant that's going to be using a lot of tool calling, then using something like GPT 4.1 would be great. Number three is temperature. Now, if you need your AI assistant to be very predictable, maybe it needs to follow a script or a certain path, and then setting the temperature to a lower number, something like a 0 or even up to a 0.2 would be perfect for those type of scenarios. But if you need your AI assistant to be a little bit more creative, and then we can set it to a higher number, something like a 0.6 or a 0.9. Lastly is the max tokens. It's very important to not set it too high, which can lead to a lengthy rambled response, and we don't want to set it too low where it leads to our AI assistant getting cut off mid-response. Finding the sweet spot, I find it that 300, anywhere around there is ideal for real-time voice AI assistants. Now, if this helped you, please do me a favor, hit like, comment, and subscribe so that more builders find this resource. My next video, I'll drop on how to build a lead reactivation system that can call old leads. With that said, my name is Quincy, and I will see you next time. Peace.